Okay, welcome back. We're on page 794 or thereabouts, talking about the history of NFS. And this time, instead of just being boring history, there's an awful lot of stuff to learn here, so kind of pay attention. So we talked about how the second version, well, version 3, did asynchronous writes, which means I didn't have to wait. And it really sped things up a lot. And then in version 4, they said, okay. We got to make this compatible with lots of other systems, and, other people other than just Sun Microsystem are using this. So we need to break it up into components and have something talk about, replication and how to migrate and, access control list and, handling Unicode. So it was a major rewrite to basically make it work in foreign languages and to make it work on other versions. Okay, so typically what happens is a single install of the current version of NFS can handle all of the previous versions. In other words, if I install the NFS client on my machine and start talking to an NFS server, it'll say, I prefer version 4. And then the guy says, no, I don't have 4. Well, how about 3? I don't have 3. You got 2? Yeah, okay. Well, then, it just negotiates. So it can handle it all. So clearly it wants to use the best, but it has to negotiate. Okay, so version 4.2, which came out, that's basically the last version that came out in 2016. And it basically says, okay, we've got a problem here. We need to keep track of, we need to be more stateful. We need to switch over to a different network stack. We need to do lots of things. So hang on a second. We'll talk about that, those changes in just a minute. So now behind the scenes, okay, Sun Microsystem came up with this thing called remote procedure calls. And the idea is I want to talk to the kernel to open a file, but I don't want to open it here. I want to open it on the server. So the client machine asks for a remote procedure call, RPC. Now, RPC was written specifically for NFS. That's how it was created. Specifically to make it so you could do remote calls on a kernel that's on a machine that, connected via the network. Now, however, that term doesn't mean that now. Remote procedure calls is used by everybody now. Microsoft uses it. Everyone uses it. And basically, it just means a way to send a request through the wire and have the other end do something and send something back. So now it's kind of a generic term. Remote procedures calls, not specifically for NFS. You can do remote procedures calls for, like cameras and voice and, all sorts of stuff. So you can do a remote procedure call that says, hey, do I have permissions on this file? And then it comes back and says, yeah. And it says, oh, I'd like to do another remote procedure call. Please open that file. And he goes, okay, here it is. Okay, now I will do another remote procedure call. Please read me the contents of that file. Okay. And then I will do another remote procedure call. Please close the file, right? So I'm just doing remote procedure calls. Okay, cool. So now we talk about transport. I kind of alluded to this a little earlier, how you transport things back and forth on the network. So in the old days at layer 4, version 2 of NFS used UDP at layer 4, not TCP. So it was a lot faster, but it did pass the buck. It basically said, I absolve myself of all responsibilities for this packet making it through intact. If something goes wrong, that's your problem. You need to fix it. That's what UDP does. Okay. So, is UDP a routable protocol? Can I route UDP across the internet? Well, yeah, I can route it across the internet. Is that a smart thing to do? No. No, it's not. Across the internet, there's a lot more possibility of things going wrong. And so, let's just say, for example, in the TCP model, I have a client that talks to this guy, and then it talks to that guy, it passes it from like one router to the next. This router goes to that router, that goes to that router, that goes to that router. In the TCP model, any one of these things can say, wait a minute, I see a problem, let's fix it. Okay? But in UDP, I'm on the West Coast and I want to talk to somebody on the East Coast, and I go through 5 routers to get there. So I go to the first router, second router, third, fourth, fifth, and I finally get to my destination. Here, the routers are going to say, ain't my problem. So if there's a problem, and I have to say, wait a minute, give me that one again, that's a hell of a lot of work, right? So it's clearly not a good idea, although not like it's not possible. Yes, you can route with UDP. It's just a heck of a lot better if you don't. Okay. Version 3, they said, well, give you a choice. You can use UDP if you're on a local network. Made sense. Or version, go to TCP if you're using the internet. Kind of cool. And then version 4 came up and said, screw that. Let's just switch over to TCP and be done with. Okay. So it'll run everywhere. We don't have to think about it. Okay, that kind of made sense. Let's talk about state versus stateless on page 769, or 96 rather. Version 2 and 3 were stateless. It had no idea if somebody had mounted a file system on their client and was passing files back and forth. It didn't know, didn't care. But version 4, the current one we're using, is stateful. So it does keep track of open files and locks on files. Because remember, somebody has to be the traffic cop. So now it's taking on that responsibility. Okay. Exports. So in the Windows world, we call them file shares. In the Linux world, we call them file exports. They mean the same thing, and quite frankly, I don't really care which term you use. On the other hand, if you're trying to impress somebody in an interview, call it a Linux export. Don't call it a Linux share, just because you could go, there we go, ooh, okay. That would be impressive. So those are directories that are made available on a server that you can connect to from another machine. So try not to call them shares. I have a tough time not calling them shares. Okay, file locking. So, even let's forget about NFS for a minute. How to do file locking between two people trying to hit a file on the same disk? I mean, we're talking about one computer, no network at all, right? You have two users on the same computer, and you're trying to do file locking. That's actually pretty tough to do. I mean, there's an awful lot that has to happen. The playing traffic cop on the file system is a royal pain in the ass. And it's kind of difficult to do, even if you just got two people on the same machine. Now, take that and say, well, now I've got 100 users and they're all over the world. How difficult is it now to do file locking? Oh boy. So version 4 put the file locks into the file system. They said, okay, hang on. Rather than go to the kernel and doing file locks, we'll take care of file locks for you. That way, since we're now stateful, we can do that. It wasn't really a choice before. But now that we've gone stateful, we'll keep track of who's doing what and who's got what control. So the server now is smarter. The NFS server is smarter now and can keep track of file locks without bothering the kernel, because quite frankly, that was a tough thing to do to begin with, and doing it on the network even made it worse. Okay. File security on the 798. So versions 2 and 3 were absolutely horrible. They basically just said, hey man, is your machine okay? Yeah, my machine's okay. Then great, you just get everything you need, and whoever the hell you say you are, that's good enough for me, and we'll just go from there. Wow. So it was not written with security in mind, okay? It was they were looking at it from, you're inside a corporate LAN where there are no bad guys, okay? There's nobody trying to sneak in. There's nobody tapping the wire to listen on things, right? So version 2s and 3s were designed not for the internet. Now just shooting things across the internet, holy moly, I need to be doing things slightly different. Maybe I need to be thinking about encrypting things back and forth, and I need to do an awful lot more that just flat wasn't available in version 2 and 3. So there's some choices, and we'll talk about this in a configuration environment in just a minute. One of them is called auth none, which basically means no authorization whatsoever. Just hey, dude, whatever. The other one is called auth sys, which means I use the user and group authentication on the machine. But again, that's kind of clumsy because I'm having to trust the client. I'm trusting the client that when he says my name is Bob, he really, really is Bob. Okay, that's a little funky. And then a more appropriate one is using a third-party system. So yes, most of the time now when you see NFS, it is using some sort of a third-party configuration. To tell you the truth, Kerberos is a technique you can do to do that. But quite frankly, using Active Directory, if you're in a mixed environment with a lot of Windows clients, let's say the Windows clients outweigh the number of Linux clients by like 3 to 1 or something like that, well, then it kind of makes sense to use the Microsoft Authentications model and just basically say, hey, when we connect to this, Linux share, we're just going to go grab the Microsoft Authentication and do that. Okay, that's just a very, very common way of doing it. Rather than using any of the techniques they talk about, we'll just punt it upstairs to somebody else to do. Okay, so let's go back with authsys one more time. So if I'm on my machine, and remember how when we created your own account, and then in assignment 3 we had you create a Bob and a Sue. Okay, so most likely your user ID is 1000 or 1001. Yeah, 1001. Bob is probably 1002, and Sue's 1003. Okay. So you have another client over here that did the same thing, but they did it in slightly different order. They created their own account, got 1001. Then they created Sue's account first. She got 1002. And then Bob got 1003. So now we have a mismatch. The 1002 matches 1003 over here, and 1002 matches 1003 over here. So Bob is Sue, and Sue is Bob. Okay? So when we connect using the simple authentication system, where each machine has to say, well, I'm Bob. Well, maybe you are, and maybe behind the scenes you're actually Sue. So man, oh man, that is clearly not exactly the way to do things. So, could Bob see Sally's files? And could Sally see Bob's files? Yeah. Yeah, they could. In fact, they won't be able to tell them apart. As far as the server is concerned, Bob is Sally and Sally is Bob. Kind of weird, huh? So, using this RPC sec with Kerberos is clearly a good example. Using RPC sec with other type of third-party thing is another option. We're not going to go into those guys. I'm just saying that, of the two major options, no authorization whatsoever, are using the user ID and group ID on the individual clients. That one's scary. The real answer, of course, is using RPC sec with some sort of third-party thing. Kerberos, Active Directory, something. Some sort of directory services thing. Okay, so now we kind of talked about how you can fake out a user. So there's some scenarios where you want user mapping to occur. You actually want it to occur, unlike the scenario I just described. So a user, a user app, okay. Let's say I just went and I said, okay, I just want to get the listing of the files in my home directory. I just want to do an ls-al. Okay, where did that image gray come from? Well, it came from my machine, right? It said, hang on a second, I see a user ID, let me go look it up. Oh, I see a group ID, let me go look that up. If I was to do an ls on a network share, what would it have to do? Well, it would have to go look up the user not on my machine, but the user on the server, right? So there's an ID mapping that has to happen. It has to basically say, okay, hang on a second. I don't really want that one. I want the one over here. Kind of makes sense? Okay. So here I'm just using my local stuff. But there, they need to have some other way of doing it. So because of that, remember how we talked about how when you attach a disk, that you really don't want the set user ID thing to come across, right? So if I'm an administrator on my PC, I sure the hell don't want to give root powers to that network share. So I need some way of squashing root to be able to pull that off. But hold that thought because we're coming up on the 15-minute